Our lesson on geometric progression continues. Our lesson on, or our class on geometric progression continues. Before going to the sum of GP, which is for geometric progression, I would like us to take this question. Let's solve it under the n term of a GP. The question says that e.g. 6. The question says, the following gives a geometric sequence 2, j, k, and 250. Find the value of j and k. We should find the value of j and k. Firstly, what is our A? A is the first term, which is what? 2. R, which is the common ratio. Question mark, no common ratio there. We cannot say j divided by 2. Or you say equals to j divided by 2. That is our common ratio. We don't know it. Then what else? The following gives a geometric sequence. Count 1, 2, 3, 4. Thank you. T4 equals to the last term, 250. So it says the last term is 250. Now we can start our working. How do we work this? We now says that a raised to power n minus 1 equals to the last time, which is 250. A is 2, so we say 2 r raised to power n minus 1. What is our n? Our n, which is still 4, our n equals to 4. 4 minus 1 equals to 250. So 2r, 4 minus 1, 3 equals to 250. You divide both sides by 2. 2 here 1, 2 in 250, 125. R raised to power 3 equals to 125. R raised to power 3 equals 125. We are looking for ordinary R, not R raised to power 3. Then we have to move the raised to power to this side. R equals to, when it's moving to this side, it becomes cube root. Then what is the cube root of 125? That is 5. 5 times 5, 25 times 5, 125. Now that we have gotten our R, which is our common ratio, then what will now be our j and k? So we can say j equals to common ratio, which is R times what? Common ratio R, that is j equals to common ratio R times what? First term multiplied by first term, which j equals to, what's our common ratio? 5 times the first term, which is what? 2. J equals to 10. So j equals to 10. Then what is our k? K 2 equals to common ratio, which is R times j, whereby k equals to, what's our common ratio? 5 times 10, which equals to 50. So that is our answer. We can now move on to our sum of GP. So We have gotten the answer we are looking for there. We can now move on. And if there is anything they ask us to find again, there is nothing. We are only to find the value of j and k, which we have done. Now we have the value of j, we have the value of k. So we can move on. Now let's go to sum of GP. We now move to sum of GP. Sum of geometric progression, which is GP. In sum of geometric progression, we have two formulas we normally use in sum of geometric progression. What determines this is our R, which is common ratio. Is our R greater than 1 or less than 1? Whenever our R is less than 1, we say that Sn equals to A in bracket open 1 minus R raised to power n bracket close 1 minus R, whereby we have our R is less than 1. But if our R, which is the common ratio, is greater than 1, we say the formula will be A in bracket R raised to power n minus 1 bracket close divided by R minus 1, where R is greater than 1. So these are the two formulas we have in solving geometric progression. You have to be very careful here when you are solving geometric progression. First, check what your R gives you. If your R is greater than 1, you use this formula. If your R, which is your common ratio, is less than 1, then you make use of the first formula here. Let's pick an example here. E.g. 7. Find the sum of the ninth terms Now the question says that find the sum of the ninth terms of the sequence for 20, 100, 50. Then we have solution. In our solution here, what is the first term? A equals to 4, R equals to 20 divided by 4, which equals to 5. Our R here is 5, which is our common ratio. Finally, then we have what? Our N equals to 9. Now we want to solve. We now say what's the Xn? Xn equals to our R is 5, which is greater than 1. We apply this second formula. A in bracket R is power n minus 1 bracket close R minus 1. Now S9 equals to A. Our A here is 4. 4 in bracket R raised to power n. Our R is 5 raised to power n, which is 9, minus 1 bracket close divided by R, which is 5 minus 1. S9 equals to 4 in bracket 5 raised to power 9. 5 raised to power 9 5 raised to power 9 will give us 1953 125 minus 1 divided by 5 minus 1, 4, which 6 to power 9 equals to 4 in bracket. This minus 1 will give us 1953 125 124 divided by 4, whereby s raised to power 9 equals to. Now this multiplied by 4 equals to 7, 8, 1, 2, 4, 9, 6. Now we say divided by 4. Our final answer equals to, when we divide by 4, we now have 1, 9, 5, 3, 1, 2, 1, 2, 4, which is now 1,953,124. This is our final answer. Now, we can move on to second example. After getting our answer here to be 1,953,124, we can now move down to second example on sum of a GP, which will be our example 8. In example 8, we have in our example 8, we have the question, the third term of a GP is 63, while its fifth term is 567. What is the sum of its first 7 term? Now, we say the third term of a GP is 63, while its fifth term is 567. What is the sum of its first 7 terms? Solution. In this, our A we are not given, our R we are not given. The first thing we are given here is the third term of a GP is 63, which is a 63 equals to 63, while its fifth term is 567. T5 equals to 567. This is what we are given. Then, what is the sum of its first 7 terms? Firstly, let's find our A and R first. Using these two we are given, T3 of 63, that will give AR is power n minus 1. A we are not given, R we are not given, n is 3 here, minus 1 equals to what? 63. Which will give us AR raised to power 2 equals to 63, equation 1. This will give us equation 1. Then here too we have AR raised to power n minus 1 equals to 567. AR raised to power n is 5 minus 1 equals to 567. AR 5 minus 1, 4 equals to 567, equation 2. Now solving equation 1 and 2 simultaneously, we now have AR raised to power 2 equals to 63, equation 1, and AR raised to power 4 equals to 567, equation 2. Then what do we now do? We divide equation 2 by equation 1. when you divide equation 2 by equation 1. So AR4 divided by AR2 equals to 567 divided by 63. Now, we can now move ahead by saying that A cancel A here, we now have R for this R raised to power 2, R raised to power. When it comes here, it will become minus 2 equals to 567 divided by 63. We now say 567 divided by 63, which will give us 9. Now, R raised to power 4 minus 2 equals to 9. R raised to power 2 equals to 9 will now become R equals to, you bring it here, will become square root 9, where R equals to 3. Now that our R give us 3, then we can now look for our A. You now say solve for A using equation. Solve for A using equation 1. Our equation 1 here is now A raised to power 2 equals to 63, where we now have A, our R is 3. 3 raised to power 2 equals to 63, where we now have 3 raised to power 2, 9. 9A equals to 63. 9 here 1, 9 is 63, 7. A equals to 7. Now that we have gotten our A to be 7, then let us look for the sum of its first 7 terms. Now we want to look for the sum of its first 7 terms. Now, x, this one will now say x7 equals to, what is our R? 3 is greater than 1. So I will say that whenever our R is greater than 1, we apply the second formula, which says A in bracket open R raised to power n minus 1 bracket close divided by R minus 1. So our x7, 7 term equals to A, which is 7, in bracket our R, which is 3, n, which is 7, minus 1 bracket close divided by R, which is 3 minus 1. So which equals to 7 in bracket 3 raised to power 7, 3 raised to power 7 will give us 2187 minus 1 divided by 3 minus is 2, which equals to, permit me to play here, now which equals to, so x7 equals to 7 here in brackets 2187 minus 1 will give us 2186 divided by 2. x7 equals to 2186 multiplied by 7, 15,302 divided by 2. x7 equals to, we now divide it by 2, we have 7651. 7651 as our final answer. We are through with geometric progression. This is all for now about geometric progression. In the classroom, what we'll be meeting, may still have opportunity to solve more questions on geometric progression. But before the classroom, I believe with these examples we have solved, you would have much knowledge about geometric progression. And when it comes to the classroom, you will find it more easier to solve. And the lesson will really flow a lot. Thank you.